talk about the cosine of 60 degrees. 1/2. So you agree with me that the sine of 30 degrees and the cosine of 60 degrees is 1/2. Let's talk about the cosecant of 30 degrees. 2. I agree with that. What about the secant of 60 degrees? Secant of 60 degrees? 2. Because secant's reciprocal of the cosine. How about the tangent of 30 degrees? 30 degrees, remember, is pi over 6 in radians. Square root 3 over 3. And then what's the cotangent of 60 degrees? Again, cotangent of 60 degrees is the same as pi over 3. It's what? Trick question? Square root 3 over 3. All right. Now, I picked these pairs on purpose. Let's talk about the first pair that I picked. Sine of 30 and the cosine of 60. What's the relationship between 30 degrees and 60 degrees? Going back to some geometry, what's the relationship, remember, between a 30 degree and 60? If you add them together, they add up to give you what? 90. They're complementary angles. So let's talk about cofunction identities, because this is the next set of formulas you have to remember. Cofunction identities, what do you notice about the sine of 30 and cosine of 60? They turn out to be exactly the same. So cofunction identities work just like this. If you see that you've got a pair of complementary angles, and one angle is sine and the other one is cosine, sine and cosine are cofunctions of one another. Again, think of the CO for cofunctions, CO for complementary. So sine and cosine go together. So if these angles are complementary, then that means at these two angles, the sine and cosine values are going to be exactly the same. And obviously, since secant and cosecant are the same, are the reciprocals, secant and cosecant are also cofunctions of one another. Tangent and cotangent are also cofunctions of one another. Again, the tangent of 30 degrees is going to be the same as the cotangent of 60 degrees. So if you know the tangent of 30, you know the cotangent of 60 degrees. They are going to be exactly the same. That's the way cofunctions works. All right, so that's your first set of these formulas that we're looking at the top, these cofunction. Again, pi over 2 is 90 degrees. So if I take 90 degrees and subtract an angle from it, it's going to be the same as the cosine of that particular angle. So remember, sine and cosine go together. Those are cofunctions. Secant and cosecant are cofunctions of one another. They go together. Tangent and cotangent are cofunctions of one another. All right? So now, it's pretty obvious when you're going to be dealing with cofunction problems, because you're going to be seeing angles that are complementary, angles that add up together to give you 90 degrees. That's a red flag that it's probably going to be some type of cofunction problem. So for example, take a look at 12 degrees and 78 degrees. Are 12 degrees and 78 degrees complementary angles of one another? Yes. So then I know that the tangent of 12 degrees has to be equal to its cofunction, which is cotangent, and the complement of 12 degrees is 78 degrees. So the tangent of 12 degrees is going to be exactly equal to the cotangent of 78 degrees. Now, even though 12 degrees and 78 degrees is not from our unit circle, we're going to be able to work these problems out without a calculator. Because again, I can take the tangent of 12 degrees and replace it with a cotangent of 78 degrees. So the cotangent of 78 degrees minus the cotangent of 78 degrees. What is the cotangent of 78 minus the cotangent of 78 going to give you? 0. So when you see those complementary angles, that's a red flag that you're probably dealing with some type of cofunction problem. All right? So take a look at number 3. The cosine of 40 degrees divided by the sine of 50 degrees. Again, look at the relationship. Are 40 degrees and 50 degrees, are they complementary of one another? Yes, so that's probably mean that we're dealing with cofunction identities. The cosine of 40 degrees then has to be equal to its cofunction, which is the sine of the complement of 40 degrees, which is 50 degrees. It doesn't matter, eeny, meeny, miny, mo, it doesn't matter if you change cosine into sine or change sine into cosine, but you want to change them into the same trig function so we can simplify it. So I can replace cosine of 40 degrees with a sine of 50 degrees. So what would the sine of 50 degrees divided by the sine of 50 degrees be equal to? 1. So even though these angles are not from our unit circle, by using cofunction identities, we're going to be able to simplify them. Now let's take a look at number 4. 1 minus cosine squared of 20 degrees minus the cosine squared of 70 degrees. Well, I do know that 20 degrees and 70 degrees are complements of one another. But the issue is, I don't see a sine and a cosine. But what is 1 minus cosine squared, going back to that lovely pink sheet that we had before break? Sine squared. So I can change 1 minus cosine squared by my Pythagorean identity into sine squared of 20 degrees. Now I know that sine and cosine go together with my cofunctions. And again, since 20 degrees and 70 degrees are complements of one another, I know that the sine squared of 20 degrees is going to be equal to the cosine squared of 70 degrees. So sometimes you may have to do a Pythagorean identity substitution or some other substitution before you can deal with the cofunctions. Yes, Carla?
Do we have to write down what we're doing?
If it asks it for it, yes. Yes. So then I can change sine squared of 20 degrees into cosine squared of 70 degrees. So then what's cosine squared of 70 minus cosine squared of 70? That's just going to give you 0. So any questions about the cofunctions? Again, look for the complementary angles, and that's a red flag that you're going to be dealing with the cofunction identities. All right? So now, the rest of this section is just going to be dealing with our trig ratio SOHCAHTOA and looking at solving right triangle problems. Let's just review our 6 trig functions first of all. Remember SOHCAHTOA, sine represents your opposite over what? Hypotenuse. Cosine represents the adjacent over hypotenuse. Tangent represents the opposite over adjacent. So using theta as our reference angle. First of all, we only know 2 of the 3 sides of this right triangle. So before I set up my trig ratios, you want to make sure you know all 3 sides. What theorem are we going to use to help us solve for this triangle? Pythagorean. Is this side automatically going to be 5?
No.
That's a very common error. How come it can't be a 3, 4, 5?
Because the
hypotenuse has to be the longest side, correct? So be careful of that trap. Don't fall into that trap. Don't see that automatically you see 3, 4. This side has, that only works if the hypotenuse is 5. So you're going to have to use your Pythagorean theorem to find that third side. So 4 squared is equal to 3 squared plus, and I'll call that other side b squared. So 4 squared is 16 equals 9 plus b squared. So subtract my 9, 16 minus 9 is 7. So what is this third side of the triangle going to be? Square root 7. So be careful when you see that 3 and the 4. Make sure that the 3 and the 4 are on the legs of the triangle and not the hypotenuse. So now we're ready to set up the sine. So the sine of theta, remember, is going to represent the opposite. So from theta, you want to set up the opposite side, which is 3, over the hypotenuse, which is 4. What's the reciprocal function of sine? Reciprocal is the cosecant. So if I know sine, I can set up the cosecant by simply taking the reciprocal. Cosine represents what side? What's the cosine going to be? Adjacent over hypotenuse. That's going to be the square root of 7 over 4. Secant of theta is the reciprocal, which is 4 over square root 7. When I rationalize that, that's going to turn out to be what? 4 square root 7 over 7. Tangent is the opposite over adjacent. So tangent's going to be 3 over square root 7, or when I rationalize that, that'll be what? 3 square root 7 over 7. And then finally, the cotangent, square root 7 over 3. Remember, make your life easier. Use that unrationalized form of the tangent. So any questions on setting up the 6 trig ratios before we get into using these to solve? So one application that we can use these trig ratios for is we can use these trig ratios to help us solve for sides and or missing angles of a triangle. So let's take a look at this example down here. So here we have a right triangle, and we've got the angles and we've got the sides labeled as A, B, and C. So they're telling me that side A is 7. Angle beta is 50 degrees. So they want us to find side B, side C, and angle alpha. Just so you know, when you see lowercase letters in this particular unit, this represents the sides of the triangle. Uppercase letters will represent angles. Just so you can distinguish between sides and angles, if you see lowercase letters, that represents you're solving for sides. Uppercase letters means you're solving for angles. So they want us to solve for side B and C. How come I can't use Pythagorean theorem here? We don't know 2 sides. In order to use Pythagorean theorem, you have to know 2 of the 3 sides. So if you can't use Pythagorean theorem, this is where we're going to use trig ratios, the SOHCAHTOA, to help us. Now, first of all, I can find angle alpha. You know 2 of the 3 angles. What do all 3 angles in a triangle add up to equal? 180. So to find angle alpha, I know I can take 180 degrees and subtract from that the 2 angles that I know, the 90 degrees plus 50 degrees. So what's angle alpha going to be? 40 degrees. Because remember, we know that all 3 angles have to add up to equal 180. So if I know 2 of the 3 angles, I can just add them together and subtract it from 180. Now to find side B, pick an angle. Always use the given if possible. So I'm going to use angle B that they gave me of 50 degrees. Let's talk about solving side B first. So I'm going to have to use a trig ratio. If I want to solve for side B, in reference to angle beta, side B is the opposite side. Do you agree with that? So I only know one other side, which is side A. In relationship to angle B, is this the adjacent or is this the hypotenuse? Adjacent. So what trig ratio involves opposite and adjacent from your SOHCAHTOA? Tangent. So I can set up my tangent as an equation. So the tangent of 50 degrees is equal to B over 7. And I want to solve for side B. So how can I algebraically solve for B? I can do what to both sides of this equation? Multiply by 7. So 7 times the tangent of 50 degrees is equal to B. And this is where you'll need your calculators for. What mode should my calculator be in? Degrees. How come I know it's not radians? Has a degree symbol. All my angles are in degrees. Yes. So when I'm dealing with the triangle problems, you want to make sure you're in degree mode. So make sure you change your mode in degrees. And I'm just going to simply type in 7 times the tangent of 50 degrees. So 8.342. You're always going to round to 3 decimal places. So you're always going to round to 3 decimal places. Okay? So any questions on how I solve for side B? By the way, remind me again, is this exact or is this approximate? Approximate, because I rounded to 3 decimals. Yes, Carla?
Why can't we solve B with the cosine of 50?
Because remember, cosine is the adjacent over hypotenuse, so when I go to solve for side C, I will use the, because remember, cosine is adjacent over. That's what we just did, tangent of 50.
Oh, then why did we do the 30?
Because it asks to solve for angle A. Yeah. This asks us to solve for it. So now let's talk about solving for the hypotenuse. You always want to use exact values when you're solving, not approximations or values that you found. So even though you know 2 of the 3 sides of this triangle, one of them is an approximate value. So you want to stay away from the Pythagorean theorem. So now to solve for side C, I know my adjacent side. I want to find the hypotenuse. What trig function involves adjacent and hypotenuse? Cosine. So I'm going to set up the cosine. So the cosine of 50 degrees is equal to 7 over C. Now this setup's a little different because notice the variables in the denominator. So it may take you more than one step to actually isolate C. What's going to be the first step to get C by itself? Multiply. So I'm going to multiply by C. So again, C times the cosine of 50 degrees is equal to 7. Remember, I want to solve for C, so what am I going to do to both sides? I'm going to divide by what? To get C by itself, what am I going to do? Divide by cosine of 50. So I'll just type that in my calculator. So 7 divided by the cosine of 50. So 10.890. Again, you're always rounding to 3 decimal places. So there's side B, side C, and angle A. That's what this unit's going to be about. It's going to be solving for sides and angles of triangles. In this section, it's just dealing with right triangles. When we move out of this section, we'll be dealing with triangles that are not right triangles. But we're going to be just solving for sides and angles in the right triangles in this section. All right, so any questions on this one? All right, let's take a look at some more. Another review of some geometry. Your favorite. Remember angle of elevation, angle of depression? When we talk about angle of elevation, it's the angle between a horizontal line and another line if the line is above the horizontal. So for example, in this diagram, here is your horizontal. The angle of elevation is above that horizontal line. So this is your angle of elevation. The angle of depression, if the angle is between a horizontal line and another, if the line is below the horizontal. So the angle of elevation is always above the horizontal. The angle of depression is below the horizontal. Or if we talk about a line of sight, you'd be looking down for angle of depression. If you're on the ground looking up, that's an angle of elevation. If a picture is not given to you, so now we're going to get into some word problems. If a picture is not given to you, you always want to draw a picture. So let's take a look at example 6. The hypotenuse of a right triangle is 3 feet. So I'm just going to draw a right triangle. Remember, the hypotenuse is always straight across from the right angle, so the hypotenuse is 3 feet. If one leg is 1 foot, so it doesn't matter, just label your triangle so that one of your legs is 1 foot. Now here they want us to find the degree measure of each angle. So we're solving for angles now. In the last example, we were solving for sides. And I gave you 2 of the 3 angles. The problem here is I don't know 2 out of my 3 angles. So I'm just going to call this angle A and call this angle B. So if you only know one angle in the triangle and you want to solve for the other 2, you're going to also have to use your trig ratios to help us solve for these angles. Again, let's talk about angle A. Let's look at the sides you do know. In relationship to side A, I know the hypotenuse, and what other side do I know? Not the opposite, but the what? Adjacent. So I'm also going to set up a trig ratio. So the cosine of angle A is equal to 1/3. So then to solve for the angle, this is where we're going to use those inverses. Yes, Nick?
How do we know what side we're on?
It depends upon which angle you're solving for. So again, I'm solving for angle A. So in relationship to angle A, that's the adjacent. But it'll change when I get to angle B.
Couldn't I just put 1 on
Yeah.
So when we solve for B, it'll be 1 as well?
Well, it depends. The picture, the answers are going to be the same. You may just have them reversed. But again, the two angles are going to be the same.
A and B.
Yeah. Well, no, A and B are not going to be the same. But what I'm saying is, had you done angle B first, you would have used the sine instead of the cosine. It depends upon what angle.
And we would have used 1 foot for that.
Yeah, exactly. Yeah, exactly. If you put the 1 over here, you would just put it on the sine, but you're still going to get these two angles. You're going to get the same answers regardless of the order that you labeled it.
Okay.
Okay. I just called it A and B for our reference. The answer is just asking what are the two angles as your final answer. So now, before break, we took our test on inverses. Remember, to solve for angles, we have the inverse. So to solve for angle A, we're going to do that inverse cosine of 1/3. Remind me again on your calculators, where's the inverse function? Where's the inverse cosine? Second cosine. So I'll just hit second cosine of 1/3. So 70.529 degrees. Don't forget your degree symbol. Now, if I wanted to solve for angle B, in relationship to angle B, 1 foot is not the adjacent side, it's the what? Opposite. And I know the hypotenuse, so what trig ratio would I have set up? I would have set up the sine. So I could set up the sine of B is equal to 1/3. And then again, I can do the inverse sine. And again, I could just hit the second sine of 1 divided by 3. So 19.471 degrees. Okay? Yes, Nick?
Why are we doing inverse sine or inverses?
Again, that's how you solve for angles. Remember, inverses is how you solve for angles. Because we're trying to solve for angles here, so you have to do the inverse. Okay? Any other questions on example 6? Yes, Jorge.
Why is it not inverse?
Because again, remember what we talked about before break. Inverses is how you solve for angles. The only way you can get the sine to cancel out on this side is to take the inverse operation of sine, which would be your inverse sine. Remember that. If you think about how you solve equations, you always do the inverse operation. So you have to take the inverse sine to get this sine to cancel out. So you have to take the inverse sine of both sides. But inverse trig functions is how you solve for angles, remember. Yeah. Any other questions on 6? All right, let's take a look at number 7. So we have a right triangle, and they say the hypotenuse has a length of 10. So again, I'm just going to set up a right triangle, and the hypotenuse is 10 centimeters. Again, it doesn't matter where you put the 40 degrees. They're just telling you what angle is 40 degrees. So I'm just going to put that angle down there. Find the length of each leg. So again, I'll call this side A and side B. Again, it doesn't matter which side you call A and B. So using 40 degrees as my reference angle, let's talk about solving for side A first. Side A in relationship to 40 degrees is what? The opposite or hypotenuse or adjacent. What is side A? Side A is the adjacent, and I also know the what? Hypotenuse. So what trig function involves adjacent and hypotenuse? Cosine. So I'll set up the cosine of 40 degrees is equal to A over 10. Now how do you solve for side A? You're going to do what? Multiply both sides by what? 10. So 10 times the cosine of 40 degrees will be equal to side A. So that gives me 7.660. Okay. You guys go ahead and solve for side B for me. Sides and or angles if you need to. Again, you pick one angle in the triangle, and again, Eeny, meeny, miny, mo. If you know all three angles, you just got to pick a reference point. Pick a reference angle, and that's what you use to set up your trig ratios in terms of the opposite and the adjacent side. All right? So let's take a look at another example, number 8. So we have a ship that's offshore from a vertical cliff. What's significant about that word vertical? To be vertical, what's happening? It's perpendicular, exactly. So I know I've got a cliff, and again, this cliff is vertical. So I know that's my right angle. And the cliff is 100 feet high. So again, you want to set up your picture and you want to label it. So I know that this cliff is 100 feet. And it takes, from the ship, it takes a sighting to the top of the cliff. So here's my ship. Don't laugh at my drawing. It takes a sighting to the top of the cliff, and the angle of elevation is found to be 25 degrees. So here's the line of sight from the ship to the top of the cliff. So the angle of elevation, you're down looking up, that's the angle on the ground, is 25 degrees. So any questions on how the picture is set up so far? And the question is asking, how far offshore is the ship? Am I solving for the hypotenuse or the other leg of the triangle? The leg. So I'm just going to call that X. So using 25 degrees as my reference point, I know the side opposite 25 degrees, which is 100. I'm trying to solve for the adjacent side. So what trig ratio, going back to SOHCAHTOA, involves the opposite and adjacent? Tangent. So I'll set up the tangent. So the tangent of 25 degrees is equal to the opposite over the adjacent. Any questions on how I set that up? How do I, yeah, go ahead. Because in terms of the reference angle that I know of 25 degrees, I know the opposite side, and I want to find the adjacent side. So by SOHCAHTOA, what trig function involves opposite and adjacent is the tangent. Okay. So how do I solve for x here? What's going to be my first step? Multiply by x. So I have x times the tangent of 25 degrees is equal to 100. Then what? Divide by tangent of 25. So then on my calculator, I'll just type in 100 divided by the tangent of 25. So 214.451. Make sure you include your units, and this length is measured in what? It's measured in feet. So any questions? So like I said, always draw your picture if it's not given to you. So you can draw the picture at number 9. And when you're dealing with towers and buildings, what angle this section's all about? It's basically given the right triangles, being able to solve for missing sides and or missing angles by using your SOHCAHTOAs. All right, let's take a look at, we're skipping 10 and 11, so jump to page 4. Sometimes the pictures will be given to you. So we have a flagpole, just like towers and buildings. Let's hope that the flagpole is perpendicular to the ground. It casts a 60-foot shadow, and shadows are on the ground, so I know that this side of my triangle, the horizontal side, is 60 feet. And the angle of elevation to the sun is 35 degrees. Again, angle of elevation is always on the ground. They want us to find the height of the flagpole. So what trig ratio am I going to set up here? Again, I'm trying, and from 35 degrees, I'm trying to find the opposite side, and I know the adjacent side. So what trig ratio involves opposite and adjacent? That's going to be your what? Tangent. So go ahead and solve that for me. Yeah, that's perfect. Yeah, go ahead, Christian. Now, before we look at the diagram, even though the diagram's given, diagrams aren't always going to be given. And the thing about angle of depression you have to be careful of is, let's take a look at this particular example right here. A wire needs to reach from the top of a building to a point on the ground. So again, here's my building. Here's my wire. The building is 10 meters tall. Now, I know the picture's given to me, but this is why I'm drawing it out for you. Because they're telling me the angle of depression from the top of the building to the point on the ground is 22 degrees. The angle of depression is not on the inside of the triangle. When they give you that 22 degrees, remember that angle is the angle from the horizontal looking down. So here is that 22 degrees that they're giving you in the problem. Now, if you remember from geometry, there's two ways you can handle angle of depression. If you think from geometry, you guys studied a lot about parallel lines, remember, cut by transversals. Remember, alternate interior angles are in relationship what to each other? They are what? Congruent. So using your property, the hypotenuse is that transversal. So this 22 degrees has to be equivalent to this particular angle on the ground, which is 22 degrees, which is why they put that 22 degrees in the picture down here. Another way you could have handled it is there is a relationship between these two angles that are adjacent to one another. These two angles have to be complementary. So if you know this angle on the outside is 22 degrees, this angle in here has to be what? 68 degrees. So either way you want to handle it, when you're dealing with angle of depression, you either have to handle it one of those two ways. All right, so any questions on that? So they want to know how long the wire should be. So we're trying to solve for the hypotenuse. Again, using 22 degrees on the ground as the reference point, what trig ratio am I going to use to solve for this hypotenuse? I'm going to use what? Sine. So go ahead and find that length of that wire for me. Okay. Again, remember when the variable is in the denominator, it'll take you 2 steps to get that variable by itself. So we want to multiply by x first and then divide by the sine of 22. Make sure you guys are always rounding to 3 decimal places. Always, always, always. All right, any questions on this particular section? Okay, then for your homework